Hello and welcome to Hunkmat Online Academy. In this lesson, we want to learn about the straight lines. And we are going to be learning the following: Cartesian coordinates, distance between 2 points, midpoint of a straight line, parallelism, perpendicularity, equation of a straight line, gradient, intercept, locus of a point, non-linear to linear transform, also called determination law. Now let's look at Cartesian coordinates. Cartesian coordinates is a way of representing lines using x and y coordinates or x and y axis in a graphical form. So in every coordinate there are two lines, or in every graph there are two lines: the x axis, which is also called x coordinates, and then y coordinates or y axis. The x coordinate is also called abscissa. X coordinates. Another name for x coordinates is abscissa, and another name for y coordinate is ordinate. Now I say that in Cartesian coordinates we represent lines with a graph. So this is a graphical form of representation of lines or junctions. Coordinates actually means junctions, the meeting points between two lines. So if we want to get the meeting points between two lines, we use Cartesian coordinates, and we find a point where the x coordinates or the abscissa and the ordinates where they meet, and that place is the coordinate. So this is the x coordinates and this is the y coordinates. Now any junction where the x and y coordinates meet, the junction is called a coordinate. So this is a coordinate, and in each coordinate we represent it by writing the x coordinate first and then the y coordinate. So if we want to represent the coordinate of this place, we first of all put the value for x. We have x and then put comma and then we write y. The same thing with this one. Assume that this one is x1, y1, this one may be x2, y2. So this is how to find or to represent the coordinates in the Cartesian graph. Now let's look at distance between 2 points. Distance between 2 points. Now assuming that this one is a point, each junction is called a point. So this place is a point and this place is also a point. Now assume you want to find the distance between these 2 points. Let's assume that this one is A, point A, and this one is point B. We want to find the distance between the 2 points. That is this from here to here. We use this formula, which is gotten from Pythagoras theorem. In Pythagoras theorem, we say that the hypotenuse line is square of the hypotenuse side is equal to the square of the two adjacent lines. If you have a right-angled triangle, in a right-angled triangle, one of the angles is 90 degrees, or there is a perpendicular side or perpendicular angle in it. If you see something like this is a sign of perpendicularity. It shows that the line is a perpendicular line. Now, if you see a curved angle like this means ordinary angle. But when it is sharp, pointed, it is a perpendicular line. That means that the angle there is 90 degrees. Now, if you have x and y axis like this, and we have a line, that is a triangle actually, where we have one of the angles as 90 degrees. The side that is facing the angle 90 degrees is called hypotenuse. Now the other sides are called adjacent. So this place is called adjacent. Now the Pythagoras theorem is telling us that the hypotenuse side squared is equal to the adjacent side squared plus the first adjacent side squared plus the second adjacent side squared. Now let's call the hypotenuse h. Let's call the first side A and second side B. Now it means that h squared is equal to A squared plus B squared. H squared is equal to A squared plus B squared. Now let's look at an example. Let's see this example. If you have this triangle, and this place is numbered 2 and this place is numbered 1, and we are asked to find this side, how do we get it? Now this is a right-angled triangle. Right-angled triangle. Why? Because the side that is facing, because we have angle 90 degrees inside it. This is angle 90 degrees because it has a pointed or sharp curve, which means a perpendicular side or perpendicular angle. So if this place is 90 degrees, it means that the angle that is the side that is facing it is the hypotenuse. That means that 2 is the hypotenuse side. Now the other sides are adjacent, A and B. Now that means that 2 squared is equal to the first adjacent side is x squared plus the second adjacent side is 1 squared. Now 4 is equal to x squared plus 1, 1 squared is 1. And now it means that x squared is equal to 4 minus 1. X squared is equal to 3. And x is equal to root 3. X is equal to root 3. Example 2. If we have this triangle and we are asked to find the value of x, how do we get it? Now we have seen the sign of perpendicularity, which means that this angle is a right angled triangle. So we use the Pythagoras theorem, and that means that 3 is the hypotenuse since it is facing the sign of perpendicularity, or the angle 90 degrees. So we have that 3 squared is equal to 2 squared plus x squared. 3 squared is 9, is equal to 4 squared. 2 squared is 4 plus x squared. Now x squared is equal to 9 minus 4, which is equal to 5. Now x is equal to, we take the root of 5 to clear the power of 2 in x. So x is equal to root 5. This is the answer. Now this is a quick review on Pythagoras theorem. Now let's see the distance between 2 points. For 2 points, like we have here, this junction here in this coordinate forms a perpendicular line, since it is a pure vertical line meeting a pure horizontal line. Whenever a pure vertical line, that is a vertical line that is not bending, when it meets a pure horizontal line, two of them will form a perpendicular junction. So we cannot say that this place has a perpendicular angle. Now, if that is the case, and we are looking for the distance between A and B, that is the hypotenuse, that is from here to here. Now, if that is the case, what we need to do is to find the value for this side and the value for this side. Once we get it, the x side and the y side, then we can say that the square of, let's call this side now h, the distance between the A and B. If you call it h as the hypotenuse, the h squared is equal to the x squared plus y squared. Now our work now is to find the x and y. Now without doing much work, it has been found that x, or let's find it here, assuming that this place is, let's call here y1 and this place y2. Now this one x1 and this one x2. Now the distance between y1 and y2 is equal to y2 minus y1. So this side is y2 minus y1. Now why the distance between x1 and x2 is equal to x2 minus x1. So we can now use the Pythagoras theorem to find the distance between the 2 points by saying that the line AB, which is the line between A and B, is equal to x plus y, which is now x2 minus x1 squared. Line AB squared is equal to x2 minus x1 squared plus y2 minus y1 squared, because these two lines are now the adjacent lines while AB is now the hypotenuse. So we can also say that line AB is equal to root of x2 minus x1 squared plus y2 minus y1 squared. So this is the formula that you can use to find the distance between two lines. Let's look at some examples. If we have that, you can be asked to find find the distance between A, line point A is equal to 3,2 and point B is 4,6. Now solution. A 3,2 means that this is x and this is y. We can call this one x1 and y1, and then b, 4, 4,6, this is x2 and this is y2. So it now means that if we use our formula that line AB is equal to root of x2 minus x1 squared plus y2 minus y1 squared, then we are going to have that line AB is equal to root x2 is 4 minus 3 squared plus y2 is 6 minus now 2 squared. Okay, So we're now going to have root 4 minus 1, 4 minus 3 is 1 plus 16, 6 minus 2 is 4, 4 squared, 4 squared is 16. So it becomes 1 plus 16. And now we have line AB. Line AB is equal to root 17. This is the answer. So this is how to find the distance between 2 points, and which we got the formula using Pythagoras theorem. And you've also learned the meaning of coordinates, the x coordinates and y coordinates. So this is what we have in this lesson. In our next class, we continue with the other parts of the topic. Thank you.